Hi and welcome back to DACAScript. So today we're going to be going over a bit of a generalization kind of approach of looking at how you design a database from start to finish. So this could be used with any sort of SQL. It could technically be object-oriented. We're going to be doing two parts of this video. So this video is going to be going over the kind of like theory, what you should be considering. We're also going to go through some sort of requirements that we get and how we actually split that out into a kind of UML type diagram. So actually how we model that in a database structure, and then just kind of like go through the entire structure. But I'm going to do a part 2 to this video where we actually go into SQL and we start building those objects as well, if you're interested in that side of it. So I will link those two in the, or I'll link that one in the description when that one's up. So let's get started anyway. So with your any sort of development, this is with application development and also database development, there is a development cycle. So initially you'll get some sort of requirements through. Now these can range, we'll be talking about this quite a lot in a bit, but these can range from really like simple little requests to full-on specifications for some sort of requirement, meet some sort of requirement, whether it's national requirement, whether it's just Bob down the road wants a database to track his airplane models or something like that. You know, it can be really simple and it can be really complicated as well. So once you've got those requirements, you are going to do an analysis on those. So you're going to look at those requirements and actually see, okay, have we got all the information we need? Do we need to have a chat with whoever's actually given us the requirements? Do we need to understand everything more? And also, this is where you can do your feasibility. So you can actually go, actually, that's just not possible. You know, that's going to take us 1,000 million years, or we're going to need 400,000 staff members in order to implement that. So you can do all of that in the analysis stage. So you don't actually do any designing at that point. You're just looking at very, very high level, not really skimming, but you do start to cut it down. It's just that you look at it from a very high standpoint and see how much work is required on a very basic level. Now after that, you get onto your design phase. So this is when you're actually designing the actual product. You aren't actually doing any code at this point. You are literally going, okay, this is what I think it should look like, this is what I think this should look like, this is how I think it should join up, and you start to do those kind of models. So this is where UML comes in really handy. It's actually very good UML, but that's where you start to do those kind of things to try and make sure you don't miss anything on that point. Then after that you do your implementation. So that is actually writing, well, partly in design and partly in implementation. This is kind of like middle ground where you're actually putting that into practice. But I typically say implementing something, you're actually doing it, and it will be into like some sort of dev system. So this is a user acceptance testing UAT environment or some sort of development environment. So you actually build it to make sure that what you've designed does actually work. Then after that you do some testing. So does that actually meet the requirements? Almost every stage should go back to that. So just go, okay, I've designed something, does it meet the requirements? Have I implemented it and might have made some changes between these two? Does it meet the requirements? And then you actually do a formal test cycle. So this is a proper test cycle where you will be testing it itself, you have somebody else test it for you, and ideally whoever's actually come up with the requirements, or somebody from this side, whether it's a business kind of requirement or something like that, so say a whole department asks you to do something, one of those people should be able to test it to make sure it meets what they think it is, you know. And then if they're happy, which is great, you get to do a deployment. Now in my experience, this is always a cycle, because once you've deployed it, there's going to be something else that they forgot to tell you about, or they expected was in it and it didn't get picked up in testing, it didn't get picked up in any other stage at all. They expected you to do something without telling you, which always happens. It's either that or new requirements come in. So, you know, you deploy this, maybe this took 3 months to do the whole thing, and there's some new requirements of some kind. So it's always this cycle of growth, which is quite good because it makes it quite simple, and once you use it, it's yeah, you're used to it then, which is good. Okay. So a couple other considerations, kind of words of wisdom. Always ask questions during requirements and development type stages and analysis stages. Literally, I cannot stress this enough. Don't make it... What a lot of people are afraid of is sounding, you know, making it seem like they don't know anything about it. But assume that you don't, because as soon as you start assuming things, you know, put things down even in quick discussions and things like that, and just say, this is my understanding of it, and then they might say, yeah, that's it, but actually we also do this. You know, don't be afraid to ask questions. It will save you a lot of time in the future, because you won't be trying to undo things, you won't be trying to remodel things later on, and it ensures that you actually do stick to your schedule as well, which is great. So building a solution with a client, a lot of I'm not going to go into like the project management side of things, but actually things like Agile do stress this quite strongly, which is building a solution with a client really does help. Now that doesn't mean that I have to be sat next to you while you're writing code or while you're designing things. It just means like having regular meetings with them and regular informal chats, emails, that kind of thing. So you might be with obviously we're talking about database, but if we were talking about an application, you could actually give them a screenshot and say, this is what I'm thinking the splash page will be, your initial page that people come onto. What do you think? And you just do a mock-up. You're not actually building anything on there, you just kind of done the layout. And you can just send that over to them and say, that looks good or that doesn't look good, and try and open it up. It also means that you get a really good really good relationship with the client as well, which is good. So if you're a company, or if you're in a bigger organization and you're just a department of it, that's always a good thing. They do think that you are competent, that you are keeping them in the loop. They then know where the progress is as well. It's just a lot better way of doing things, and it makes sure that there's less chance of mistakes. There still is, there always still is, because they'll assume something that always happens, but it at least helps in that. Always think about speed and efficiency and scalability. There is so many times that I've seen the scalability and efficiency thing put to a side because they go, it's only going to be used by 10 people. Everything scales at some point. It really does. And then they've had real speed issues in the end because it's done in an efficient way and it's not been built to scale. If you do it at the beginning, not only is it going to be faster when even just 10 people are using it, it's going to be alright when you start using the thousands, and then you're just really looking at infrastructure in order to bolster that up, because your design will be really good. So always keep this in mind. Pretty much question everything you do. So when you're designing things, we'll be talking about that in a second, and I'm going to be putting things out there which I will question on my own design, which I've done, which I've oversimplified for this this kind of presentation, this kind of tutorial type lesson we're going through. And also do think about security. So security is one of those things that bores a lot of people, but it is very important. So think about how you're going to control security, if it's going to be done at application level, if it's going to be done in Active Directory, and etc. and so forth. All of the kind of security stuff, it doesn't really matter too much with a database design, but it could be that from a database point of view, there's really clear roles or not even roles, there's really clear departments within your requirements, and you split those into schemas so that it's clearer from a security point of view where you should be given access to. So if you've got a sales schema and you've got a load of tables in that, and you've also got a finance schema and you've got a load of tables in that, it makes it a lot easier when somebody from finance asks you for access to something, and you can question it a lot easier from a ongoing basis rather than actually from the initial design point of view. But it does help, it really does help, though it usually falls apart because there's always somebody that works 2 days in finance and 3 days on the shop floor or something like that. There's always going to be a little bit of a difference with it, but at least if you've got them in both roles on, like, say, Active Directory or in SQL, then they've got access to both of those, which is good. Right, so if we go and cut up the requirements a little bit, so this can just be a simple list. It can literally just be, we've got a system that needs to store circles and squares and the sizes of them, and that's it. It could be really simple like that, or it can be completely complicated. So I work in the NHS. We have got some very, very complicated specifications that come out from NHS Digital from a national point of view. Very, very complicated. We're talking hundreds of objects, which have then got an API on top of that, so you're actually building objects which can either be in JSON or XML. They are very complicated specifications, very, very complicated. But you can also get really simple kind of specifications. So again, working on local solutions that I've kind of built, they can really be so simple as like a conversation. Just say, can we do this? So I'll give you an example. A file gets kicked out every 3 months, and that needs to be encrypted and sent via secure SMTP to a set person. And at the minute, at the time, it was actually a manual process, so it was just literally make that automatic. So file gets kicked out, process picks it up, encrypts it, sends it on its way, and audits the entire lot of that. Really, really simple type of thing, but that is a simple bit of requirements which has from that design aspects as well. So It can be both, or it can be a complete mix of either of those, or it can be very complicated. It can be in the middle. It can be massive as well. So during requirements, do look at the feasibility, see if you can do this. If you're a company, a small company, say a software kind of like house, do look at if this is actually within your means, because what you don't want to do is accept a contract for something that you can't actually deliver on, that is too over-ambitious. But what you can also do here, and what I'm not saying is, I'll go, that's too big for our company, we can't do that, okay, just drop it. I'm not actually saying that. What I'm saying is look at if it's feasible and potentially go, actually look, right, okay, we can meet 60% of your requirements within the timescale that you want us to do it in. But those 40% we're not going to be able to do because our team's quite small. So there's different ways we could do that. We can either go, okay, let's do a phase 2 and we'll meet those 40% of those requirements the year after in second year of development, or you can give us some more money, we'll get another developer in. There's those kind of things, but do look at it and have an honest conversation with whoever's the client on this side. So feasibility doesn't just mean your physical list of requirements, it also means the timescales that are involved. It's more project manager, which I'm going into, which I'm going to try and stay away from. But do you think about it? Do you think about that kind of side of it? Now the other thing is prioritization. This is probably the most key thing that never gets done properly. A lot of people will give you a list of requirements and they won't say which they need, which they want, which they would love to have, but actually if it wasn't delivered, it wouldn't actually matter. And this is probably the most important thing, to go back and just go and just look at them, analyze their requirements, see the common themes, and go, okay, look, I'm guessing we need to do X, Y, Z, and you'd love it if we could do some sort of thing. So we're going to build that into the design framework that we're going to be doing. So make sure you always do have a discussion, get the priorities, try and keep them about 60% of the entire requirements as your must requirements. If you use something like Moscow prioritization, which is in the Agile framework, that's what I actually use. It does work. However, you always find that it's never 60%, it's just that it should be. But people like lots of things these days. Too used to apps, I think, is the problem. Right, so an example of requirements. We're gonna actually do a practical example. I think it's the best way to actually step through. So we've got a guy called Jeff. He's the owner of 3 different stores, and he's got one warehouse. He is wanting a system to track requests made by sales personnel to the warehouse to replace the existing telephone paper process. So what happens at the minute? Say Fiona, who's working in one of the shops, they don't have the stock in the shop. She will call the warehouse, and then what the warehouse will do is they'll get that item onto a van at some point, which will go back to them. It's all via telephone and it's via paper, so there's no audit, there's no guarantee. There's been problems with that actual system going from A to B. So the owner is actually going, okay, well, the company's grown, he's now got 3 stores, he's got one warehouse, one central warehouse. He wants to actually be able to track these electronically because he's probably thinking about expanding. So we can take quite a few things from these requirements, which is quite good. But as you can see, that's a really simple set of requirements, but actually the model from that is quite complicated. He's actually not said what tables he needs. He hasn't said what data he needs. He has said what data he needs to store. He said that you need to track requests. It needs to be mobile sales personnel and the warehouse. And like we were saying, or like I was saying earlier, with all of the different kind of things that we need to actually think about, we do need to think about things like security. So we've got sales and warehouse. Well, there's a logical split between those different staff. And we've also got these locations, so we've got 3 stores and we've got 1 warehouse. Well, I'm thinking about that. So if we have a look at what I've done to cut these up. So this is the analysis stage of this. So looking at it, okay, we need some sort of request table because requests are going to come in, as we saw earlier from here. So go track requests. We're also going to need a product table. So products are going to exist in the store. They're also going to exist, of course, in the warehouse. So, what are you requesting? Makes sense to have a centralized kind of list from that, and it will link to a request, so you request a certain product. Also staff, so we're going to need some sort of way to identify staff so they can be audited. And also some sort of location, so we've got those 3 stores and we've got the warehouse as well. Now those are probably going to expand, so we want to do that in a way which the system can expand easily without us having to rejig. So we don't want to have a store table or anything like that, or we don't want to hard set it in request. We want to say that it's requested from store 1 and it's going to warehouse 1 or whatever, or ignore warehouse 1 at all because we've only got one warehouse. We want to make it so it's expansive, so we're going to have this location table which can be accessed by this request table as well. So looking at design, if we look at some fields for the request table, this is just what I've come up with, and you guys can disagree as much as you want, which is absolutely fine. Quite happy with that. ID being a primary key, as always, so you can just delete it and mark it as deleted or whatever. Got a requester that's going to have the foreign key to a staff. Going to have a request date, because I think that's pretty important. You know, when was it actually requested, so you can actually order by inside an application. It's something that people usually forget about. Request location, so that's going to be a foreign key to the location table. Also going to have the product, which is going to have a foreign key to the product table. Priority, which is foreign key to priority. Now that one is something that I would discuss with them, absolutely, because they might go, nah, they're all high priority. But they also might go, actually, yeah, that's a really good idea. So try and, when you're looking at requirements, look at what they exactly need and then separate these ones out where you need to have a discussion with them and say, look, this is what I'm thinking of having, and point these out, like really point them out, because if they just look at like something like this, they won't have a clue what you're talking about. Also a status. Now that's pretty important, I think. Something that is not said within the specification, however, I think it's really important because you need to have a status type column to say, you know, this is a new request, it's been accepted, it's been rejected from the warehouse, it's en route, and it's completed or something like that. And from an application point of view, that you can just filter on that kind of status column to see where things are, to say if it's not completed. Something like that would just then bring up the unique list of where everything is. Which is good as well, so you can actually see that. Now, one thing to note, you could actually have a completely separate table to if you needed to store what time each of those events has happened. So that is one of those design choices which is not really questionable, but it could be questionable, where you could say, actually, wait a minute, that should be a different table. You should actually have a request status table, and that just logs the ID against it, and then the status at that point in time. And that's literally it, I think, is probably all you need. So you just need the ID and the status and just a time, ID, status and time, and that would be it. So you could do something like that, but for my example, I've made it a lot simpler. I've actually just cut it out. So that's one of the things I've done there to kind of like cheat. I've also got the filler as well. So this is the actual staff member who has picked up that order and is responsible for that request, even so not order, request in the warehouse. So they've picked it up, Fiona's requested it, and Bob, who is in the warehouse, is actually the person that's going to be filling that order. So he's in charge of, okay, right, I've picked it up, I've got the item, I've put that on a van, and it's going to be with you, within 2 hours or whatever it is. And then of course the filler location as well. So this is something that, although we've only got one warehouse, I think it's very important to have the ability to have multiple locations, even though at the minute it'll just be one. And it could be, from an application point of view, it defaults to one, warehouse 1 for the time being, and then they can just have that expanded, or they can just have that as a drop down anyway, so they just add a location to the location table, and then the application has automatically expanded itself, which is great, people absolutely love that when they can locally configure things. Also a date as well, so the date that order has kind of like been filled, a sent date, so when it's physically sent, left the facility. Receive date as well, so that's when it's been received back to the requester, and also a last updated. These are really useful. Last updated type fields, can't stress enough how useful they are. So it's going to be a little bit difficult to scroll back, there we go. If we get back to here, so free stores, so we've got this request, wants a system to track requests, so we want to track requests, which is quite good. So we've kind of got that, which is good. So we've got a request table. And sales personnel can do it. Yep, we can have whatever, any sort of staff member can actually probably do it. We can do like roles and things like that off of that, which is good. And they can make it to the warehouse. Okay, that all works. Excellent. So that's good. That's what we want. So if I just scroll down, here we go. So if we have a look at the next one, which is product table, I've gone for an ID of primary key of just a usual ID, standard integer. Now, product is going to have a category, because it probably does. Probably also has a subcategory. These two could be discussed. They could actually say, yeah, actually they do. Yeah, you're right, because we actually do TVs or we do electronics as a category, and then we've got TVs, radios, etc. and so forth underneath it. Yeah, it makes sense to actually be able to see how many requests we've had going to the warehouse. So these are like these extra bits which you can throw into design, where it doesn't really cost you much to do, but when they start asking for reports and things like that, you don't have to do any really horrible matching where you build your own lookup table for it. So you can actually get a bit more money coming in as well. Also got a description of that product, which makes sense. Deleted. Now that's a logical deleted. Typically, especially working in the NHS, we don't really delete anything. Not really. We mark it as deleted, which means that it doesn't appear anymore within the application. However, on the database, you've just got a 1. So usually this would be a default of 0, and it's actually a 1 now. An example of this, say they've got a TV made by some made-up company called Mabu or something like that, I don't know, Mabu, and they were selling Mabu TVs for, throughout the 90s, and then in 2000s, or actually that doesn't make any sense, it doesn't really relate to today. So they've got some TVs that are selling by a company called Mabu, and they've been selling them pretty good. They're getting loads of requests coming in. That company then, Mabu, goes bust. There's no more TVs for them. So you just delete this. You just mark this as deleted. You don't actually physically delete it, and that means that all your previous requests, so when you're pulling stats and things like that, you don't have to affect any of your queries at all. You don't have to, go, wait, that's disappeared. It hasn't actually disappeared, because all of this works. This foreign key doesn't get broken, and it's all there, which is great. So it's a really good thing to do. And then say if Mabu then suddenly makes a comeback and they're selling the exact same stock, which would be very bizarre, but could happen. They're selling the exact same stock, you just unmark them as deleted. It's available in the system, which is great. So for a staff table, this is going to be really basic kind of stuff. So I'm just going to skip a little bit through this, but title, first name, last name. Now job title and a foreign key to job title, you don't have to actually do this, but typically companies will split everything up into either roles, so those are like company roles, or job titles are probably more used. So you have manager, store manager, warehouse manager, warehouse worker, sales worker, senior salesperson, finance, or whatever. Now they can have multiples off of that, as I did say earlier. So this could be a separate table where you have staff roles or staff jobs or whatever you want to call it. It's always a bit of a difficult one with that one actually, but yeah, we're going to have that, and we're also going to have the username. So we're going to say it's Active Directory, and this is how we link it to an ID for them. So they log in with Active Directory, it then grabs the ID in the application, and they can use that for adding stuff in, which is a nice, easy way of doing it really. And of course it's deleted because they could leave, and they could also come back. So that means that you've got one record per user with one audit trail. Some organisations that I've come across do actually, if a staff member arrives, they give them an ID, they leave, they mark it as deleted or hard delete it, which I think is a stupid thing, but they can hard delete it, and then when they come back, they create a brand new ID. I don't like the idea of that, because from an audit perspective, most things are going to be tied into this ID, so I think that you should actually always try and use the same thing. You should keep this record forever, really, so you've always got it. Anyway, for a category table, what I've gone for is really simple. So it's got an ID, it's got a description, and it's got deleted. So that'll be your electronics. So ID of 1, electronics, and it's not deleted, or it is deleted. Say if the store actually changes or adds anything in, then they can again locally add to this list, which is great, which is always good. For a subcategory, very, very simple. Very, very simple. It's just got ID category. It links back to the subcategory. Sorry. Doesn't link back to the subcategory. It links back to the main category group. So this would be, electronics, and then this would link to, say, TVs or something like that, televisions. And again, it can be deleted, it can be removed from that. So priority, very simple. A lot of these lookups are really simple, so I'm going to skip through them. So I got ID, description, deleted, updated, and request table, request status table. So this is the lookup actually. So I can't call a table request status, as I said before. So maybe this is a bad choice unless I put a schema in it, so that'd be something to think about. So yeah, ID, description, deleted, and last updated. You might want to delete a status, so you don't want to know if they've been accepted anymore. You just accept if they've been put. They should be on the, they shouldn't have to update it or something like that. I don't know. There's a load of different reasons that could happen to change this. And then job title, again, simple lookup, ID, description, deleted, and last updated. So location table, a little bit different. So if I just get all of these in, I wish I'd done the PowerPoint a little bit easier than this, but that's the way it is. So for the locations table, ID is the primary key again. This time we've got a location type. As we knew from the specification, the kind of requirements, we had 3 stores and we had 1 warehouse. So how do we, with these requests, you would expect it only to be a request from the store to the warehouse. Could be the other way around, but if they wanted to put and this will be one of the questions that you ask them, if you wanted to put an actual constraint on that within the application, a location type is brilliant for that, because you could say, okay, this location is called, I don't know, store in London, for example, and then you might have another one which is store in Birmingham and whatever, I don't know, who cares. You could actually have a location type of store, so you could actually have, whatever it's called, and then put it in the address line is always a good idea, because then if for whatever reason, say that the warehouse needs to know which store that is, they can go, oh wait, yeah, they've actually changed the name, it's not London anymore, it's not the London shop, they've now called it Kingston or something like that. Well, the address might not have changed, it might just be they've renamed the store, which does sometimes happen. Because you're using an ID and you're using the ID on that to join it up, great, you don't need to worry about that, this is just a physical description. Now, if the address did move, but it's the same store, same store, same personnel, for some reason they didn't want to create a new location, which it could be, the address changes, then you can at least update that, and when it does a print off to say at 10 o'clock, they look at all the new requests that have come in, see if, grab all that stock and everything like that, and see where it needs to go to. You could have this printed on it. You could do like a nice report in reporting services, or something in the application that does it, which grabs from it, which means that you can dynamically update this, which is great. So there we go, postcode deleted, updated, all that thing. But the main thing to think about here is this location type, where you could say warehouse, store. If they then wanted to add in, say, head office, maybe they expanded even more, you can then put in head office. You could do a load of different things. You could do outlet, sales outlet as well. There's a load of different types you can do, and you've already expanded that. So locally configured is great. It's not so good for future business, but well, actually it is good for future business. If you've created an app which allows them to the app to expand automatically with them through configuration, they're going to be very happy with you. So they're more likely to stick with you than go for a different supplier. Whereas if you didn't have something like this and it was all hard set, they might go, okay, we need to probably replace our system. We can't do it with this one, and the company's quote is too high. They're on a tight budget these days. Everyone is actually on a tight budget. They can at least expand this when they do get some money and they need to add something into it. Say instead of it, has a request, they also want to have like some sort of travel. I don't know. They want to do it into put the loads into a different table which actually says which van it is or whatever. They might then, or they'll be more likely if you've got a good design to actually pay you for it, which is good. Anyway. So location type, again, simple table, ID description deleted and last updated. Say for example they got rid of all their warehouses and instead they started buying bigger stores, and those stores have got a warehouse on the second floor or something like that. They might do that. I can't see it happening though. So once you've got through that kind of design, and I do recommend you guys doing it where you do cut it up and you start logically looking at things. I do recommend building a UML diagram. UML it's kind of like its own language, and I've actually done something really bad here where I've used the wrong arrows. So I'll admit that I actually haven't used the language properly, but for demonstration purposes it's fine. I admit that it's wrong, so I know that somebody's going to say it anyway, so that's why I'm saying it. But you can see here at least the relationship. So we've got all of those tables that we just discussed. We've kind of like linked it all together. So we've got okay, so the request table is the heart, really. It's a system for tracking these requests. And they got this requester, and that is a staff ID, and that's got a job title which links to job title. Excellent, cool, that's good. And you also got your request location, and also your filler location linked to a location that links to a location type. Cool. And you've got all of this stuff, so it's all kind of, you get this kind of idea of it. And we got all of that from what was a very simple. Very, very simple. If we go back, list of requirements. It's a shame there isn't a faster way of going back, really, isn't there? Yeah, I don't think there actually is. So simple requirements of this. We've gone from this very, very simple. Track requests from sales personnel to the warehouse, and that's it. But we've actually built quite a complicated looking kind of diagram. There we go. But that would actually fit. That would actually kind of meet the requirements. It might not meet the requirements for the future. Like I said, with a status, they might want to be able to track different statuses at different time, see how long a new request comes in, how long it takes for it to be accepted by the warehouse. They might want to know that. The only way they'll be able to know that is from having, well, they'll be able to, maybe this filler date, maybe, but it might be a bit loose, so they might want an extra table off of that. You could ask them about all of that stuff. And if you're a company, you could even ask them for a little bit more money if they want those kind of things, and that can be part of the negotiation. Say, okay, well, this will meet what you've got in your specification, it'll be on budget, it'll be on target, but if you're looking for doing X, Y, Z, well, we can do that for an extra 5,000 or whatever it is. You know, you can put those kind of things in, and you can say, well, it's going to save you money. You know, if we did it in the future, it's probably going to cost you 7,000 because we're going to have to do a complete system change. Now that can expand out forever, so be careful with it, because they will then think that you're taking the mickey, and they will. But you can at least be, you know, honest with them and just say, look, are you thinking you're going to need to do that? Okay, well, let's write that into it. Let's do it at the beginning. And if you build a product which is like that, most likely you can take this product somewhere else and sell it just as is, locally configure stuff, and you're off, which is great, which is even better. So let's talk about a couple things that I think is that I've kind of like skipped over on this. So one of the things, staff, like I said, with a job title, it probably isn't going to be one-to-one with those two. There could be staff that work in finance, you know, 1 day a week, and actually they're on sales the rest of the 4. It's just that they're helping out in finance and they've got some background in that. Or you could have a lot of things. Actually, you could really have a lot of things. You could have it where you link staff to locations, for example, as well. So you could have that linking across there. Probably not as useful for, well, it's not useful for the request. It doesn't really matter unless you wanted to put a constraint on the request location to say only staff that actually work at that location can request it for that location, because we haven't actually thought about that. That hasn't been linked. Now for this example, again, I'm keeping it simple. I've been trying to miss these things on purpose so that I can fit the UML diagram on the screen so you get an idea of it without going into far too much detail. But that would be something, if I was doing this for real, I would link these two together and enable a many-to-one locate thing, kind of like a relationship. So you'd actually have one staff member could be working at multiple locations. They could even be in the warehouse 1 day of the week, and 4 days of the week they could be in another location. But for this, you would probably just need to know what locations staff members are available to get at. So it would just be a separate table. So this would link to a different table here, and the same with the filler location. Actually, with the filler location, doesn't really matter unless you wanted the filler to be linked to location. But again, that linking table that you'd add in would work for that, which is always good. Another thing which is really really simple is something like your product. Okay, and this is something that you probably wouldn't have thought about, and it's language. So say if you wanted to start selling, you're selling in the UK, you want to start selling in France. You've got the same product, but in a different language, it's called something else. Your staff are obviously speaking French, so they wouldn't necessarily recognize the English version of it when they're selling a French product, and all their signs in the shop are different. So instead of having a description on here as a single thing, you could actually have it linked, so you could have a product, you know, language or product description, then it has product ID, the language code, which would link to another table, and then you would have a description. You know, you could have that in that language. Then, depending on the language of the actual system, it picks it up, it does the join, it grabs it from there. You could do that for pretty much everything. You really could do it for everything if you wanted to do it. If you had one system to do everything, that's only if you had one system to do everything. If you took this system and took a copy of it, put it in France, it's not a problem because you can just rename the descriptions. And when your head office wants to pull data, as long as your product IDs link up, and they probably won't, it will probably start off, you know, really well, and then it will go out. As long as those were the same, you could do some stats on it, because you could then just link it and bring it back in the English description, or you could bring it back in the French one, or whatever. But I would recommend, if you've got the one system type approach, then it does kind of work for that. I don't think there's too much else, except for probably this filler date. I would have to go, what does that actually mean? And a status table would actually alleviate that, because then you've got the sent date and received date. Well, you can actually cut those up and actually do the status. So actually almost getting that status table, an actual repeating status table, would actually be a good idea anyway, because then you can get rid of these dates. Request date, get rid of it. Filler date, get rid of it. Send date, get rid of it. receive date, get rid of it. Keep the last updated though. So probably what I'm going to do in part 2 now, I'm actually going to change it because I think it's a good idea. But this is one of the reasons that you should do UML as well, because you can start looking at it. Right, so implementing it is doing it in SQL. Like I said, we're going to do another video on that, completely on that. One thing actually to note back on the design side of it, going back to this, get somebody else to check your design against the requirements. So this is really important. We actually do it at my workplace and it works really well. I can't really stress it enough. It's a bit of a pain because it does take quite a lot of time. We've only got 2 developers doing it, so there's me and another guy. So you know, when we're not developing, we're checking somebody else's either design or we're checking somebody else's code. So it means that your resource is going to be stretched a lot more. However, there's a lot less chance of making a mistake and going, they actually didn't mean it like that, they actually meant it like that. They will ask questions and get a really good relationship going with your developers. It also means that you get more open to different ways of designing things, and it gets you more of a standard model. Because say for example, if I was making this and no one was going to check it, this status thing where I've got all these different dates is a bit of a rubbish way of doing it. But I might just go, tell you what, I'll get away with it, it'll be fine. If somebody else checked it, they would pick up on that. They would go, why the hell have you got these 4 dates when you could just have some sort of status thing? They're all linked to different statuses. They're hard set. What if you extend this status and then what are you going to do? Extend this table. You're going to have to then do an application change. And exactly. So you start getting to that point where actually making a smart design choice at the beginning does make sense, which is why I'm going to change it in part 2 so that you guys can't tell me off. But honestly, it really does help. It does work. Don't show this to, well, you can show this to your client, but it'll probably just make them go, why are you showing this to me? This just looks like a load of guff. This doesn't mean anything to me. But you could, if you split it up a little bit more logically, then maybe. Usually what I've found when you're talking to somebody, give them process diagrams rather than giving them stuff like UML. Process diagrams work where you go, okay, you're going to have a person that comes in, they're going to go for a request. That's going to automatically timestamp when that request is made. Now they're going to have a request location. They're going to have to select a product, a priority, and that will automatically set a status. You know, explain it to them, and you're basically going through each of these fields. It's just you're doing it in a way where you're explaining what's going on. They go, then it gets picked up by somebody which is you know, in a warehouse, so they get automatically added onto this table, so they're audited, as well as the location they picked that up on. Now, most likely you're actually requesting to a location, because you're saying, I'm requesting from store 1, I want it from warehouse 2 or whatever, you know. But it could be that this just goes out to everyone and then they pick up depending on what the stock is. You know, it could be automatically allocated from there, which is something we actually haven't put in. We haven't put in any inventory or any stock at the minute, which is I didn't want to go into because it adds another diagram that looks like this where it's going off everywhere, because it can be quite complicated where you've got inventory, it's linked to location, it's linked to your product as well. You can have a count of the amount of products, or you can have singular products with each barcode on it, which is probably the better way of doing it. So you end up having like you just get a load more tables, which is why I ignored it completely. And I'm going to ignore it for part 2 just to keep it simple. But you know, explain it that way. That's what I recommend. Anyway, so yeah, implementation, that's your SQL. Build it in a dev and UAT. Really important to do. Don't just go straight to live. Never go straight to live. It doesn't work. It leads to it's just not good. You can't iron out the kinks in live really when it's been in use. So your testing side, ensure that the solution meets the requirements. Always go back to those requirements. You know, like print them off. Even though we're trying to get away from doing like everything on paper, print it off. Like seriously, print it off so you can tick it off. Now test end to end. So that's the entire solution. From a database perspective, we don't need to worry about it too much for this, but if you've got stuff like store procedures on there to insert it or insert data, or if you're just going to be inserting dummy data, do it as if you're going to be doing it as a person. So you go, okay, insert as a requester, and they've got a request location, and all of that kind of stuff, and then go, okay, do an update as if I was updating as a filler, and you know, do a couple of those different things. Make sure that the foreign keys that you put on there are actually correct. Make sure there's no, if you do use unique constraints, make sure that actually it is always going to be unique. You know, what happens if it isn't? You know, make sure that if you're using stored procedures, make sure it gives you back an error code that's meaningful that could be displayed to the end user. Is the other thing as well. If you can, sometimes you can't, and you just do a try and catch block, and you just catch the exception. But if there's certain things like they haven't filled in a box and the application has called your stored procedure, do a check at the beginning. We actually do this, or I've just recently done this, because it means that we can actually log it and get an email out. So we actually then get an email out. This is from an automated process, by the way. It's not so much an application, it's more well, I don't know how to explain it in simple words, but essentially data will come out automatically over TCP, gets grabbed, it gets split up into different things, it calls a store procedure in order to log it. If there are lookup fails on the database side, then it will error back itself rather than it letting it fail the foreign key constraint. And it's purely for the text that comes out, so that we can then go, there, send an email urgently to it's me and this other guy, so we can go, okay, what is that new code, and why the hell didn't we get told about it? So we can actually kick up about it. But it means that we will have, a couple failures rather than hundreds of thousands. So it's those kind of things that you can do. That's just one very simple. It's not really a simple example, is it at all? That's one example of it, which is in the real world, where adding in proper things to your stored procedures is there, but we're not talking about stored procedures today anyway. Test each scenario, so go through, like I said, step by step. Test every scenario that you can think of, and it can be really basic. Say if you go, if they say X is yes, then we do this. If X is yes, but Y is no, then we do something else, and if both of them are yes, what happens? Test every single scenario. Sometimes it's impossible because you can't test everything, but don't just tie it down to one store that you're always requesting from. Look at what happens when you request from another store. Make sure that your application, make sure that when you do those joins, it is picking it up correctly, and you haven't been lazy and hard set those values, which you shouldn't do. I can't expect you doing it anyway. It's actually more difficult, I find, to actually do it than anything. Try and break it. Like, honestly, try and throw in all the kind of crap. Try and do it where you go, okay, well, I'm gonna ignore this foreign key, and I'm gonna put in just a string text or something like that. Good errors, that's good. Do things like that where your constraints have been built to ensure good, high quality data, and try and break it. Try and make it so that you can put just trash data in. And if you can put trash data in, think about your design and go back and go, can I put in a constraint to stop that? So on a very simple level, nulls and not nulls. Really, really simple thing that you should have on every single column. But from an application point of view, make sure that you have those in there. Always have independent testing on the solution. Always, 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 always have independent testing on the solution. I can't stress that enough. To get somebody else to look at it, they will find issues with your solution. Don't be discouraged by that. Encourage it instead, because it makes you better. It makes you better as a designer. It makes you better as a programmer. It makes you better as a SQL developer as such. But really do that. If you don't have anyone to do it, come back another day, look at it with fresh eyes, and be really brutal. The business world is brutal. And it's brutal because it needs to get it right first time. Well, it doesn't need to get it right the first time. It wants to get it right first time. It never happens. But don't take it personally. Some of the kind of comments you'll get is just like, why the hell have you done that? Like with what I've already done with those different dates. Why have you done that? That's a useless way of doing it. And I actually look at that and I'd go, fair enough, actually. I'm going to change that design. Let me change that. Let me redo it. Let me then get you to re-review it again. And then they might then go, okay, you've got it better, but you've also cocked up this bit. So, take it quite lightly. It will make you grow anyway. And at the end of the day, it's meeting the requirements. It's about meeting the requirements the best you can, making it as scalable as possible as well. Alright, so on the review kind of stage, this is something that there isn't a review, but after testing I do recommend strongly having an official review. So this is your testing can be really just like, I'm just going to see what happens. I'm just going to see what happens. And independent testing might be the same, where they're going, I want to see what happens as well. I do advise doing an official review. So this is for your official documentation if you have any. Review it with your peers. So that can be them doing their own testing without you, or it can be both of you doing it testing together, or a group of people testing together, where it could be, you know, yourself, another developer, somebody who actually initiated that. In this case, it was a guy called Jeff who was the initiator. Maybe him, or he might go, actually, no, I want Fiona in sales to come and have a look. Do an official test plan, do an official review, go through it, make sure it meets those requirements that you've got. So actually, I've already said here, yes, so review it with the application team. So if you've got, as a database point of view, get them to review it with the application team. This is where you work together, and they will come up with some stuff that they go, it's a really pain in the ass that you've done this in your database design, because we have to write around it. And then you might go from a database point of view, okay, I'll take that point, that's fair enough. We've done it because of this X, Y, Z. They might understand it a lot better, and they go, actually that makes a lot of sense. But then also what you can do is use that as an opportunity to go, tell you what, because it is actually really, really complicated the way that we've done that design. I'm going to write a stored procedure, and you guys can just call that stored procedure, and that will write the data in for you. Then you're working with them, not against them, which is always good. Now, reviewing the requester, like I said, with the kind of like peer review type thing as well. Reviewing them with the requester, that is probably when you've got a finished application, so it's not so much on the database side, but everything is all part and parcel with it. Really get them to review it, make sure that it meets those requirements, and you should be fine. It's less on the database design. Most of these things are. Your database design is really to meet the data requirements rather than what they want it to look and feel like. People these days, due to like apps being so everywhere, really, you know, everybody's always on their phones. They're so used to the kind of user interface, so that's always the kind of the side of it. But actually, the data behind it is what drives everything. You know, UIs change all the time. User interfaces do change all the time. But the data structure, if you've got a solid data structure, that's not going to change as much, which is good. Because it means actually it's not good. No, I'm not saying don't make it bad, but it's not good for you because it means you get less work, but actually you'll get more work because you've done it right the first time. So you'll have less stressful work with trying to redesign something. Your application team will get less stressed with you because they're not having to rewrite the entire application for it. That's another reason why you should use stored procedures, by the way, is so that if you rewrite the back end of it, and they're always using stored procedures, which is something that I've not really seen. They try to stick to stored procedures, and then they find this one query they're not using it with hard coded into the application. But generally, if you're using stored procedures, you can at least change that design over time. But it just doesn't happen always anyway. So for deployment, here we go. I got some paratroopers on here. You'll be glad to hear this is the end of it as well. For deployment, plan. So recently I've got a change coming in. It's relatively simple, which is just updating a consent flag, and it's about 2 pages of planning because there's some stuff on a cache side, so intersystem cache. There's some stuff on our integration engine, which is also cache, but it's using some different languages. They've got their own like little bits of language inside there. And it's got some SQL changes, and yeah, it's got another bit of cache. So there's a load of different components on it, and those have all been planned out. They've then been checked by somebody, and then I'll deploy it in stages. Not because I have to, because I could script the whole thing, but because then it lessens the amount of chance of failure. The good thing with this is that it's replacing a telephone and paper method, so you can actually have both of them working at the same time. So you go store one is going to start using the electronic system, and you can actually pilot it. Pilots are always good. Try and pilot everything if you can. As well, if they don't want to do just the live orders straight away, get somebody from the store to log into the dev version, and they actually make a request to the warehouse. Get somebody from the warehouse to go onto the dev system, complete that order, check it so that the kind of system works, and therefore your data works. But that's pretty much it for words of wisdom of going from start to finish with database design. Hopefully that's helped you guys. If there's any questions at all that you have, please do feel free to comment. I'm quite happy to answer any of them. Hopefully over the last just over 5 years now, I've been doing a lot of this kind of stuff, so I've got quite a lot of knowledge in it. I've done a lot of projects, so I'm sure there's something that I can answer you guys. But also tell me how you go about doing it. If you're already in this position, how are you doing it? How are you actually going about it? Is there anything that you do differently? Is there anything that you do the same, or have you cut down on things? Have you expanded on them? Have you found that you've had to do something else? That'd be really interesting to see. But hopefully, you guys have enjoyed this video. This hopefully has helped. But yeah, thank you very much for watching, guys. I will see you on the next one.